All right. This one's a little spooky, but we're going to do it. It's going to be cool. So, this problem is a trig problem. Ew! So it's 1/2 natural log sine of 2x. Okay? And x is between pi over 6 and pi over 8. That? Okay, I thought that was weird. So it's pi over 8 and pi over 6. Okay. So what do we always do? Find the arc length with these is take the derivative of y, right? And it's in respect to x. So we got to find this. Now, taking the derivative of this, if you have went through the trials and errors of calculus 1, you know that this is going to be a chain rule. So, what does that look like? Let's write it out, okay? Let's write out the chain rules. So, if we wanted to take the derivative of this function, that would be done through setting up your inner and outer functions. Okay, because what we need to do is take the derivative of the inner function and then the derivative of the outer function and then plug it in to this kind of equation where we multiply the outer function's derivative of the inner function and then multiply it by the derivative of the inner function. So that looks like this. Our inner function here is sine of 2x because our outer function is 1/2 natural log of u. So if we take the derivative of the inner function, what we're going to find out is that we need another chain rule. Okay? And so this is going to end up looking like this, where our inner function is, hold on, I'm down here. Okay, so our inner function is 2x, and then our outer function is just sine. Okay? So it's a chain rule inside of a chain rule that I'm working on right now. So our derivative of the inner function here is 2. Derivative of the outer function is cosine. And so for this inner chain rule, I should say, we can find that our derivative of the inner function here is cosine of 2x multiplied by 2. Okay? So, oh! Okay. Oh! Okay, dude. That's fine. Just drew marker on my blanket. So, cool beans. So we found that this is technically a product rule, and it's just going to be 1 over 2x, because if your product rule is, oh, it's quotient rule. Product rule is something like this, and let's say f is 1, or I'm sorry, 1/2, then this would be 1/2 times 1 over x plus 1, the derivative of f, which is 1/2, is 0. So it doesn't really matter what that is, that goes away. And then you just get 1 over 2x. All right? So, 1 over 2x. Now, this will give you 1 over 2, and then x is the g of x, the inner function, sine of 2x, multiplied by that derivative of the inner function here, which we cause another chain rule, which we got 2 cosine of 2x. Cool. Well, we found the derivative of this. It's about dang time. In a minute, I'm gonna need a sentimental. So, derivative of y in respect to x is ultimately going to be 2 cosine of 2x over 2 sine of 2x. And that's about that. Okay? So, this is actually cosine over sine is actually cotangent. So we're going to use this identity when rewriting this. So these 2's cancel, and we eventually need to square it, right? Because eventually what we're trying to get to is to be able to plug this. We're trying to be able to do this. Okay, because this is our formula. So we're trying to be able to find a dy over dx squared, and so that's what we're doing. And so we're going to get this, and then we can plug it into here. We know our bounds, pi over 8, pi over 6, and then we can do that. So we're going to do that. So we square this, and then those 2's cancel, so this just becomes cotangent squared of 2x. Yeah. Okay, because this becomes cotangent of 2x, and I just squared that. Okay? So that's where this comes from. Now, let's actually write this integral out now. So from pi over 8 to pi over 6, we have the square root of 1 plus cotangent squared 2x. Now, you can probably look at this and you might be able to see that this is, in fact, an identity. It's another one. And what that is 1 plus cotangent squared of theta is cosecant squared of theta. So, we say that this is, actually I'll just do this. This is equal to okay, pi over 8 to pi over 6 of cosecant squared 2x. Okay? And that's just because 1 plus cotangent squared of theta is equal to cosecant squared. So that's just an identity. So now we can just say that we have an integral of pi over 8 to pi over 6 of cosecant 2x, because this is just this, and if you have this under this, that will just become this. And that's what these problems are. It's trying to have this happen at the end of it, because then you can integrate without a square root. So yeah, so we need to u sub. So let's u sub. U equals 2x, du equals 2 dx, 1/2 du equals dx, right? So, rewriting this. Now you could rewrite your bounds now. I'm going to use dummy bounds when I u sub. This becomes cosecant of u Now this is, you guessed it, another thing you have to know. So these things that are in cyan or teal, or whatever you want to call it, are kind of just like the, hey, these are like the tricky things that you need to just like know. And that's kind of why I was trying to color code it like this. So this is an integral that you kind of just know. It's like if you had a cheat sheet, you put that integral on there. I'm not one that's going to be able to prove to you why this is. I don't have the proof for this. I also just like understand that this is what that integral is. So this is actually natural log of tangent. So if we write this, this becomes the natural log of tangent of u over 2 okay, and that's because this is just the integral of cosecant of whatever is equal to the natural log of tangent u over 2. Okay? So, now that we have that, okay, there's a 1/2 in front of this though. So this becomes 1/2 multiplied by natural log of tangent, and then remember u is 2x over 2. And then we would say that this is from pi over 8 to pi over 6. Okay, this can be rewritten as 1/2 natural log of tangent of x from pi over 8 to pi over 6. And so now we can do fundamental theorem and say that 1/2 times natural log of tangent of pi over 6 minus natural log of tangent. Am I seriously rewriting this like that right now? Pi over 8 to pi over 6. Pi over 8 to pi over 6. So 6 minus pi over 8. And then this is, so if we wanted to say that there's technically another thing that we need to know, is that the tangent of pi over 6 is equal to 1 square root of 3, and then the tangent of pi over 8 is equal to the square root of 2 minus 1. So, because of that, if we wanted to rewrite this as natural log of 1 over square root of 3 minus natural log of square root of 2 minus 1. So this I feel like is fine, but it's technically because these tangents can equal these that you can rewrite it. But I think this answer is okay. But yeah, it's a lot of these things in cyan. All 1, 2, 3, and 4 are the kind of just the tricks that you need to know for this problem. And so, yeah, just knowing trig identities is frustrating with a new problem that you're coming across, because it's like I can't just know that, but you do the problem more than once, and you start to retain it.